factor by grouping. So when all of the terms of an expression share a common binomial factor, so no longer are we talking about factoring out monomials, we're talking about factoring out binomials. Well, in that case, we can use factor by grouping to factor out that common binomial term. So let's factor this completely. Notice that we have common factors of a plus 3 and a plus 3. Look for your binomial terms in parentheses. And then we have factors of 2 and b respectively in our two terms. So we factor out the a plus 3's, and we have a factor of a plus 3 on the outside. And then on the inside, we have whatever the operation is between the two terms, and then 2 and b. Here and here, respectively. So we can factor this into a plus 3 times 2 plus b. Let's try some more examples. So here we look at the parentheses and see x minus 1 and x minus 1. So that's what we factor out. And then what remains inside is this x and x plus 1, its own set of parentheses. And that is our factorization. A little more abstract, but here we have a times quantity b plus c minus d times quantity b plus c. So the same quantity, same variables. We factor out that b plus c, and we're left with a minus d. That is our factorization. Okay, so how about here? Here we want to make two groups. And then ask ourselves, what can we factor out? What's the GCF in this subgroup? What's the GCF in this subgroup? Well, we have an x we can factor out here, and a 2 we can factor out here from these terms. Then we would have x times the quantity x plus 3 plus 2 times the quantity x plus 3. Now that we see our binomial factors, we can factor those out. And we get x plus 3 in parentheses times x plus 2. And that's factored. Likewise here, we want to make two groups when you see 4 terms. We can factor out an x here, but there's no common factor between x and 1. except 1. Rewriting, we have x times x plus 1 plus, here we factored out a 1, so the terms remain unchanged. Then we see our common binomial factor of x plus 1. We factor that out, and we have x plus 1 times, well, the same expression, x plus 1. Right. Here we have two groups we can form. From the first group, we can factor out an x, and we would have x times 2x plus 1. Looking at the next two terms, notice that the first term starts with a negative. When that's the case, you want to factor out a negative GCF. And the GCF of 6x and 3 is 3, so we want to factor out negative 3, or else you'll have to do more work if you don't factor out a negative GCF. Factor out negative 3, and we have positive 2x, and then positive 1. We factor out those binomial factors and get 2x plus 1 quantity times x minus 3 quantity. We have an x cubed term here, that's okay. 4 terms, we can try factor by grouping. We make our two subgroups. And note that the GCF of the first two terms is x squared. We pull out an x squared from the first two terms, we'd be left with x and then 2, so x minus 2. In the next subgroup, first term is negative, so we want to factor out a negative GCF. And the GCF of 2x and 4 is 2, so factor out negative 2. We get minus 2 times x minus 2. And factoring out that x minus 2, we get x minus 2 times quantity x squared minus 2. That's our answer.